Let's look at why ions have the charges that they have. For instance, why does magnesium form ions with a charge of +2? Well, ion charge is one of those repeating patterns on the periodic table, so you can use an element's group on the periodic table to predict its charge. For instance, ions from the elements in group 1 tend to form ions with a charge of +1. Elements in group 2 tend to form ions with a charge of +2. Ions in group 13 tend to form ions with a charge of +3. Ions in group 14 can form have a charge of positive or -4. Ions in group 15 have a charge of -3. Ions in group 16 have a charge of -2. Ions in group 17 have a charge of -1. And group 18 does not form ions at all, so we say that they form ions with a charge of 0 because they don't form ions. That's a handy pattern, but it doesn't explain why those ion charges are what they are. So let's look at where those ion charges come from by looking at magnesium as an example. So in order to understand why magnesium forms ions with a charge of +2, we have to look at its electron configuration. And here is its electron configuration: 1s2, 2s2, 2p6, 3s2. Now, valence electrons are electrons in the highest energy level of an atom, and they are the electrons involved in bonding. So if we look at magnesium, the energy levels that we see here, we see energy level 1, energy level 2, this is also energy level 2, and this is energy level 3. So if we look at the highest energy level, we're talking specifically about the electrons that are in energy level 3, because energy level 3 is the highest energy level in magnesium. And in this third energy level, we just have 2 electrons. So magnesium has 2 valence electrons in its electron configuration. And we can use a Lewis dot structure like this to represent those outer electrons, those valence electrons. Now, atoms with 8 valence electrons are more stable than other kinds of atoms. And so atoms often gain or lose electrons to achieve a full octet. So how can magnesium achieve a full octet? Well, right now, magnesium just has 2 electrons in its valence shell. We could add 6 electrons to get up to that magic 8 number. So here I have a magnesium ion with a charge of -6 because I added 1, 2, 3, 4, 5, 6 negatively charged electrons to the electron configuration. The other way I could give magnesium a full octet is by losing the 2 electrons that are currently in the valence shell. Because if I lose those 2 electrons, I lose them from the highest energy level. And so now the highest energy level is not the 3rd energy level anymore. The highest energy level is the 2nd energy level. And in the 2nd energy level, I have 2 electrons from the S sublevel and 6 electrons from the P sublevel. And 2 plus 6 is 8. So I have 8 electrons in the outer shell, although we don't draw it on the Lewis dot structure because what we're trying to represent is that we lost the 2 electrons that were in the 3rd sublevel. So which one of these 2 things will happen? We always choose the path that requires least energy, and moving 6 electrons takes more energy than just moving 2 electrons. So that's why magnesium forms ions with a charge of +2. Let's look at another example of why atoms form ions with the specific charges that they have. And this time we're going to look at the example of bromine, which forms the bromide ion that has a charge of -1. And again, we're going to have to look at the electron configuration for bromine to figure out why it forms ions with this charge. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Remember, that valence electrons are the electrons in the highest energy level of an atom. They are the electrons that are involved in bonding. And here, my highest energy level, looking at the numbers at the start of the terms in the electron configuration, up to 3, 4, back down to 3, and back up to 4. 4 seems to be the highest energy level here in this electron configuration. So when I count valence electrons, I only count the electrons that are in energy level 4. These s electrons are in energy level 4. These d electrons are not. These p electrons are in energy level 4. So I'm going to count the s electrons and the p electrons. 2 plus 5 equals 7 electrons. So bromine has 7 electrons in its valence shell. And we represent that using a Lewis dot structure with 1, 2, 3, 4, 5, 6, 7 electrons around the symbol for bromine. Now, remember that atoms with 8 valence electrons are more stable, and atoms often gain or lose electrons to achieve that full octet of 8 valence electrons. So how can bromine have 8 valence electrons? Well, it could gain 1 electron here to have 8 electrons in its valence shell, in which case the bromide ion would have a charge of -1. Or bromine could lose the 7 electrons that it has to achieve an ion with a charge of +7. Which ion is more likely? Moving fewer electrons requires less energy, so we're going to go with whichever choice involves moving fewer electrons. Here we had to move 7 electrons, so this is definitely not the correct choice. We're going to go with the scenario that only involved moving 1 electron. We added 1 electron to the bromine atom to form an ion with a charge of -1.